A very good morning for all the committee members of ICMISC present here. Our topic for today's presentation is disease recognition of plants using different image processing algorithms. I am Karan Kavadge and my fellow group members are Pranav Kul, Sumita Hire, Parth Gite and Dr. Gulbakshi Dharmale. So these are the contents we will be going through in this presentation. The contents are problem statement and objectives, introduction, literature survey, methodology used, system design, developed modules, advantages and applications, conclusion and references. Abstract. Cultivation plays a vital role in the development of Indian economy. Almost 50% of the nation's workforce is employed in this industry. The Indian agriculture component is one of the most important aspects of Indian economy. So disease recognition of plant is very important so as to maintain sustainable agriculture. Different plants tend to show different symptoms when they are affected by a variety of factors such as viruses, bacteria, fungi, climatic conditions, etc. So the first step in plant disease detection is segmentation, for which K-means clustering algorithm is used, which retrieves textual features from the input image. The age detection of the leaves can also be done using the canny age detection, which pays attention to the ages in a very robust way. Then the feature extraction process is usually done using GLCM, that is gray level coherence matrix. Followed by feature extraction, the classification comprises of KNN, that is K nearest neighbor, which has an accuracy about 90% for different inputs. Another tool used for classification, that is SVM, which is support vector machine. Hence machine learning and image processing plays an important role in disease detection of the plants. Introduction. India has a population of 1.39 billion approx, and agriculture is one of the most important aspects of Indian financial system. India having a population of farmers somehow about 95.8 million, agriculture sector produces 18% of India's total GDP. So be safe to suppose that if agronomy was advanced, it would profit nation significantly. Plants are affected by various factors such as insects, bacteria, viruses, and different climatic conditions, leading them to various diseases. At the right time, farmers are not able to recognize the disease properly, so they may face a huge loss. As according to today's technology, we have various machine learning algorithms, artificial intelligence technique, which would eventually be used practically to help farmers. Plants also have become an important source of energy and are fundamental piece in the puzzle to solve the problem of global warming. So in this context, diagnosing disease is an accurate and timely way is the utmost importance. To learn about the plant disease detection, first we need to know what is the cause for plants getting affected or being diseased. Plant disease can be broadly classified according to the nature of their primary causal agent, that is infectious or non-infectious. Infectious plant diseases are caused by pathogenic organisms such as fungus, bacteria, mycoplasm, virus, viroid, nematode or parasitic flowering plant. Disease in plant can be caused due to several factors such as viruses, bacteria and microorganisms, climatic conditions, fungal infections, etc. Examples of some plant diseases are powdery mildew, black spot and spotted wilt. So here are some images showing different diseases of plants and how these diseases affect the plants. The first one is leaf affected by minuscule mite, which is a type of insect. The second one is leaf affected by fungal infection. The third and fourth one are leaf affected by bacteria and virus respectively. What is the solution for plants getting diseased? Farmers have a large range of diversity for selecting various suitable crops and finding the suitable pesticides for plants. Hence, damage to the crops would lead to a huge loss in productivity and would ultimately affect the economy. As the methods used in ancient time were time consuming, there are modern methods which makes detection of diseases just by seeing the symptoms on the plant leaves, which makes it easier and accurate as well. The main objective is not only to detect the disease using image processing technologies, it also suggests correct remedy for the problem. The first part is image segmentation, for which canny age detector can be used. The canny age detection is one of the most widely used image processing tool which pays attention to the ages in a very robust way. Canny age detection is a technique used to extract useful structural information from different vision objects and dramatically reduce the amount of data to be processed. This is used for purpose of segmentation of the affected area on the leaf. So the following figure shows the process of age detection using canny. The first step is input image, in which images of plant leaves are gathered using digital media like camera, mobile phone, etc. with desired solution and size. In the next step, the border and textual edges of the leaves are detected, and in the last step, the veins on the leaves are identified. Another tool used for classification is SVM, which is Support Vector Machine. After extracting color and textual feature, the classification is performed by using Support Vector Machine. Support Vector Machine is a linear model for classification and regression problems. It can solve linear and non-linear problems and work well for many practical problems. The idea of SVM is simple. This algorithm creates a line or a hyperplane which separates the data into classes. Experimental results show that SVM achieves significantly higher search accuracy than traditional query refinement schemes after just 3 to 4 rounds of relevance feedback. This is also true for image segmentation system. So the two main algorithm which we'll be looking through this presentation is K-means clustering algorithm and KNN, that is K nearest neighbor algorithm. So first let's get to know what is K-means clustering algorithm. The K-means clustering algorithm performs segmentation by minimizing the sum of squares of distance between the image intensities and cluster centroids. That is, the segmentation part is done by reducing the variation of distances between cluster centroids and intensities of images. This algorithm is also known as Lad's algorithm, which is a repetitive procedure which divides the information and allocates n annotations defined by k clusters, also known as the centroids. In K-means clustering, the k is the number of clusters you want to group your data points into. It has to be predefined, that is the number of clusters. Following are the steps which undergo this algorithm. The step 1 is to choose k primary cluster, that is the center. In step 2, we have to compute point to cluster center space with other observation to all centers. In step 3, the cluster should be assigned to each observation with closest centroid. In step 4, we have to find and analyze average of the consideration with every cluster to obtain latest center position. And lastly, we have to repeat step 2 to 4 until all cluster allocations remain unchanged. The next algorithm is KNN classification, which is the K nearest neighbor. KNN is the classifier used for various classification difficulties. It does not need any information of SVM or any additional machine learning algorithm. It's not necessary to train new skills if new working form is bounded on existing set. Before new vector element classification, distance matrix should be used for comparison with training sample. Its K nearest neighbor is further taken into consideration where most occurred class among neighbors are weighted via measurement of distance. Proper flow of the system rests on appropriate collection of limits, which is K, that signifies number of neighbors to give a class to the newer elements. KNN algorithm stores all the available data and classifies as new data point based on the similarity. This means when a new data appears, then it can be easily classified into a well-suited category by using the KNN algorithm. The KNN algorithm is a simple, easy to implement supervised machine learning algorithm that can be used to solve both classification and regression problems. In KNN algorithm, assume that the similar things exist in close proximity. In other words, similar things are near to each other. Advantages of K-means clustering are: it is easy to implement, it has high speed and accuracy, and it is measurable and efficient in large collection of data. Advantages of KNN classification are: it is very easy to implement, the classifier can be updated online at very little cost as new instances with known classes are presented, and it is also versatile, that is, it is used for regression and classification. The application of K-means clustering algorithm are: it is used in document classification for identifying crime localities in a city, and it is used for fantasy league player stat analysis. An application of KNN classification is that it is used in the agriculture sector, used for understanding and managing financial risks, and it is also used for trading futures. So this is a flowchart representing different processes which undergo in plant disease detection. The first step is input image followed by pre-processing, then segmentation and feature extraction, then feature selection, and lastly classification. Now we will see the existing methodology for plant disease detection. The process of plant disease detection system basically involves 4 phases. The first phase is image acquisition. This process requires fetching of image via external media devices such as camera, mobile phone, etc. with appropriate size and clarity. The image database is important as it provides maximum accuracy of the used classifier in the final part of disease detection. This process is the operation of acquiring an image from a source, usually hardware systems such as camera, sensors, and so on, in image dispensation and machine visualization. The second phase is segmentation of image. Approach of segmentation process is presentation of image in such a way that it becomes easy to understand and analyze. This part is important aspect of image processing. Usually the segmentation part is completed by the means of k-means segmentation. Third phase is feature extraction. In this step, the features from this area of interest need to be extracted. These features are needed to determine the meaning of sample image. The feature extraction is usually done using the GLCM, that is Gray Level Coherence Matrix algorithm. The last step is classification. The classification phase implies to determine if the input image is healthy or diseased. If the image is found to be diseased, some existing works have further classified it into a number of diseases. For classification, a software routine can be written in MATLAB, also referred to as a classifier. The conclusion of this presentation justifies that KNN method used to spot and categorize several diseases that is present in plant leaves tend to have maximum accuracy while compared with different image processing algorithm. The bifurcation of the disease part is executed using the K nearest neighbor classifier, and GLCM textual features are being operated for the classification and feature extraction respectively. The KNN classifier grounded bifurcation outcome gives us optimal accurateness in plant disease recognition. Also, the classification criteria of the KNN on plant leaf viruses likewise offers maximum precision, and projected KNN and GLCM grounded tactic has better results while comparing it with other present approaches. Following are the references we went through while making this presentation. That's all about the presentation on plant disease detection using different image processing algorithm. Thank you to every committee member present here, and have a good day.